Imagine an aircraft that weighs nearly 600 tons, carries over 800 people, bends its wings several meters in flight, and can evacuate every single passenger in just 90 seconds. An aircraft where you can take a shower at 40,000 feet, have a cocktail at an actual bar, and fly halfway across the planet without ever landing. But here's the most surprising part. This engineering giant nearly destroyed the company that built it. This is the Airbus A380. And by the end of this video, you'll understand why the largest passenger aircraft in history is also one of the most fascinating paradoxes in aviation. Stay with me, because some of these facts will completely change the way you look at this plane. The first thing that sets the A380 apart is pure scale. Its maximum takeoff weight reaches around 575 tons. To put that in perspective, that's the weight of a fully loaded freight train several dozen cars long. The wingspan is nearly 80 meters, comparable to the length of a football field. The height is about 24 meters, like an 8-story building. But the real defining feature isn't the size, it's the architecture. The A380 is the only airliner in the world with a full-length double-deck layout across the entire fuselage. On the Boeing 747, the upper deck covers only the front section. On the A380, 2 full levels run from nose to tail. It's essentially a flying multi-story complex. And all of this lifts off the ground thanks to aerodynamics, 4 massive engines, and enormous composite wings. That architecture translates directly into capacity. In the certified single-class configuration, the A380 can carry up to 853 people. That's an absolute record for passenger aviation. Airlines rarely use such a dense layout. More commonly, it's 450 to 600 passengers across 3 or 4 classes. But the very possibility of seating over 800 people on a single aircraft speaks to the project's scale. One flight can transport as many people as live in a small village. And this wasn't just a matter of adding seats. It meant recalculating everything. Floor loads, emergency exits, life support systems, cabin pressure, air conditioning, power supply, baggage compartments. From the ground up, the A380 was designed to move massive passenger flows between major hubs. And in terms of raw capacity, it remains unmatched to this day. Now here's where it gets really interesting. With all that size and weight, you'd expect the range to be limited. It's the opposite. The A380 can fly up to 9,000 nautical miles, roughly 15,000 kilometers, depending on the version and payload, without a single stop for refueling. That translates to ultra-long-haul flights over 17 hours on routes like Singapore to Los Angeles or Dubai to New York. Cruising speed is around 900 kilometers per hour at an altitude of 12 to 13 kilometers.
At those altitudes, the air is thinner, drag is lower, and efficiency climbs dramatically. The secret isn't just fuel volume. It's aerodynamics. The A380's massive wing generates enormous lift with relatively low specific fuel consumption per passenger. And here's a counterintuitive detail. The longer the route, the more cost-effective the aircraft becomes. Takeoff is the most expensive phase in terms of fuel. Once the A380 settles into cruise mode, it sips fuel far more efficiently than most people realize. That's exactly why it was built, as an intercontinental giant for transoceanic flights without intermediate stops. Speaking of fuel, the numbers are staggering. The A380 can take on approximately 320,000 liters of aviation kerosene. At full capacity, that fuel alone weighs about 250 tons, nearly half the aircraft's total takeoff mass. Fuel is stored in the wings and in central fuselage tanks. And here's the fascinating part. The distribution isn't static. Specialized computers constantly transfer fuel between tanks in flight to maintain perfect balance. A full refueling can take up to 3 hours and cost over $200,000 depending on kerosene prices. But when you calculate consumption per passenger, the A380 suddenly looks very different. Thanks to the huge number of seats, specific fuel consumption per passenger kilometer can actually be comparable to much smaller airliners. But maybe the most visually striking part of the A380 is something most passengers notice through the window: those massive wings. In flight, the wingtips can flex upward by about 4 meters under heavy loads, and that's completely intentional. If the wing were rigid, shock loads during turbulence would concentrate at the wing root, accelerating material fatigue and eventually cracking the structure. So engineers deliberately designed it to flex. During certification testing, the wings were loaded to 150% of their normal operational limit. In one test, they were bent more than 7 meters upward before being pushed to destruction. Wing flexibility isn't a sign of weakness. It's a mark of thoughtful engineering. It distributes load along the entire span, reduces peak stresses, and extends the life of the structure. So next time you see those wings flexing in turbulence, that's not danger. That's the design doing exactly what it was built to do. But as impressive as the aircraft is, it has one major limitation. The world wasn't actually ready for it. The A380 is so large that not every airport can service it. Operating one requires reinforced runways, widened taxiways, enlarged parking stands, and special jet bridges with 2 levels.
When the A380 entered service, the dozens of major airports worldwide had to undergo massive upgrades. Some spent hundreds of millions of dollars on gate and infrastructure reconstruction. Even today, only around 130 to 150 airports in the world are technically ready to receive the A380 without restrictions. This was one of the biggest factors that limited its adoption. And the aircraft itself is just as complex to build as it is to accommodate. A single A380 takes roughly 3 years from the start of component manufacturing to final delivery. Sections are produced across several European countries: wings in Wales, fuselage sections in Germany and France, tail assembly in Spain. These enormous parts are then transported by sea and along specially built routes to Toulouse, France for final assembly. The final assembly process alone takes months, with thousands of specialists working on a single aircraft. In total, the A380 is made up of more than 4 million individual parts, supplied by roughly 1,500 companies worldwide. It's one of the most complex civilian engineering projects in history. Despite all that size and complexity, the A380 still has to meet the exact same strict safety standards as any other passenger aircraft. Under aviation regulations, a fully loaded plane must be fully evacuated in less than 90 seconds, with half the exits considered blocked. In 2006, Airbus conducted the certification test with 853 volunteers and crew members on board. The aircraft was completely evacuated in 78 seconds, under limited lighting, with some emergency exits closed. 12 seconds under the limit. That single test proved the world's largest passenger aircraft could meet the same safety bar as everything else in the sky. And here's something that genuinely surprises people. Despite its size and 4 massive engines, the A380 turned out to be one of the quietest large airliners ever built. Airbus invested heavily in aerodynamic wing optimization and engine noise reduction. Compared to previous generations of wide-body aircraft, noise levels during takeoff and landing were noticeably reduced. Many airports reported a drop in noise complaints after the A380 entered service. And inside the cabin, passengers consistently described the atmosphere as remarkably quiet compared to older jumbo jets. So with all this engineering brilliance, you'd expect the A380 to be one of the most successful aircraft ever built. It wasn't. In fact, it nearly became a financial catastrophe for Airbus. The program was originally estimated at around 11 billion euros. By the mid-2000s, it had blown past 18 billion. Production delays, wiring problems, and the complexity of coordinating international assembly led to years of delivery postponements. In the end, Airbus delivered only 251 aircraft, when they originally expected to sell far more. Despite the engineering mastery and the love passengers had for flying on it, the A380 program was never able to fully recoup its development investment. Production officially ended in 2021. And maybe that's the most interesting lesson of all. The A380 is an engineering masterpiece, was king a machine that pushed every limit of what a passenger aircraft could be. But it proved something uncomfortable about modern aviation. Technological greatness doesn't automatically translate into commercial success. Sometimes the most ambitious thing you can build is also the one the market wasn't quite ready for. The A380 didn't fail because it wasn't brilliant. It was too brilliant, too big, too specialized, too ahead of an industry that was quietly pivoting towards smaller, more flexible twin-engine jets. And if this video gets 1 like, I'll release a follow-up, another 10 incredible facts about the A380. And if you write in the comments that you want a continuation, I'll do 20 facts about the Boeing 747, and there'll be no fewer surprises.